You know, I spend a lot of time telling you guys how these circuits work, but I never really, I guess, show you how they operate. You just have to take my word for it that it operates this way. And um, I think if I explain some of these things on Logisim, hopefully you'll get a better grasp of it. So for this video, I just want to show you how to build the half adder in Logisim, and then we can apply different inputs to the half adder and to the and see what the how the output changes. And you'll see that it'll follow the truth table that we have designed for the half adder. All right, so let's make a new circuit here. Let's call it the half adder. All right, so we know from the video of understanding half adders how to build the circuit. So that's what I'm going to do right now. So let me go ahead and get all of my puzzle pieces out. Alright, so we're going to start with the sum first. We're going to build the sum part of the circuit. Alright, and then now we need an OR gate, I believe. We want a small gate. I'm going to put it here at the end, and let's connect these. Okay, and we know that our inputs are A prime B and A B prime. So we're going to need two NOT gates. Alright, let's connect these up right here. And then we also know that our carry is a 2-bit input. Alright, so let's have one of these be A and the other be B. Alright, let's connect them all the way out here. Put one here and one there. And we'll label the first A. This one we will call A. And this one we will call B. Simple enough. Alright, so now, oh, wrong button. Okay. So this one should then be connected to A, and this one will be connected to B. And then we know that the carry is A and B, so it should be connected like that. And then let's connect our outputs here. So this is our sum, and then our carry. So S for sum, right? And then C for carry. Alright, so that is basically the essence of, well, okay, that is the essence of the half adder. So let's fiddle with the inputs A and B and see how our output changes. So let's set A to 1. Okay, well 0 plus 1 is 1 and carry is 0, that makes sense. Alright, what about 1 and 0? Well, 1 plus 0 again is has a sum of 1 and a carry of 0. And then what if A and B are both 1? Well, 1 plus 1 carries a 1, but our sum is 0. So this seems to be operating correctly. So let's go back to our main circuit, and let's take the half adder and show our condensed circuit. So remember from my video understanding half adders that we drew the circuit and then we compressed it into this little box, and that's exactly what I just did here. Drew the circuit, now I compress it into this box. Let's have our inputs A and B and our outputs that are the sum and the carry. So this we'll label A, and this we will label B, and here we will label sum, and here we will label carry. Okay, well, if I have 0 plus 0, I have a sum of 0 and a carry of 0. Well, that makes sense. And 0 plus 1, I have a sum of 1 and a carry of 0. Again, that makes sense. And if B is 1 and A is 0, I add those two together. I have a sum of 1 and a carry of 0. Again, makes sense. And then if A is 1 and B is 1, I add 1 plus 1. That gives me a sum of 0 and a carry of 1. Okay, that's good. And now, what if we want to combine these half adders? Let's combine these. And I'll hit delete here. And I'm going to take 4 half adders. Let's take 4 half adders. Alright, so what this half adder is going to do is it's going to take 4-bit numbers. It's going to take a single 4-bit number and it's going to increment it by 1. So that means that the carry of each half adder is going to go into the input of the next half adder. And I did this on my video that shows us how to combine half adders and what they're used for and whatnot. Okay, and then for B, that's when I'll have my 4-bit number being entered. I apologize if my mouse clicks are rather annoying. Alright, so I'm going to add my inputs here. It's my 4-bit input, and then here I'm going to add 1. Alright. So I'm going to label these. I'm going to label this one increment, because we increment our number by 1, and this we will call A0 for the first bit, A1 for the second bit, A2 for the third bit, and A3 for the fourth bit. And now let's add our outputs here. And then this right here is our carry out, which we don't need to worry about for right now. So let me finish putting all this together. Alright, and now let's label these. Let's label these S0. Oh, S0, there we go. S1, S2, S3, and then C out for carry out, right? Alright, so now let's take any 4-bit number. I remember I did an example in my last video when we connected them together of adding 7 and 1. So I'm going to take 7 and then I'm going to increment it by 1. And we get 8, which is exactly what we expected. So these green lines, these bright green lines that are being lit up between the half adders, that is indicating a carry. So when we add 1 plus 1 here, we have a sum of 0 and a carry of 1. The dark green, remember, represents 0 and the light green represents 1. So let's do another number. Let's say I have 101, which is 5, and I increment it by 1, so I should get 6. And that's exactly what we get. Let's do one more. Let's do one more. Let's do 1, 1, 1, 1. Well, increment it. These all go to 0, and you can see that all the carries turn on all the way to C out. And I can turn this one off and we get 8, and then turn that one off and we get 4, 2, 1, and so on. Alright, so that's pretty simple, and that's just showing how the half adder works within a circuit. So thank you for watching, subscribe, and stay tuned for more videos. Thank you.